Alright guys, so now we're going to move on to the next page of our review. And this is determining, is it a parallelogram or not? So our first one is yes. And it's because opposite sides are congruent. And you can absolutely shorthand here. That spot where we can all see it. Well, let's put it right there. Okay. This one right here, we don't want to say alternate interior angles. The alternate interior angles are congruent, but because the alternate interior angles are congruent, what that means is this: 60 and 60 are equal, therefore these sides are parallel. 50 and 50 are equal, these sides are parallel. So we're not saying it's a parallelogram because of alternate interior angles. Alternate interior angles are congruent. It doesn't automatically mean you have a parallelogram, but it does mean that you have parallel lines. And since we have two pairs of parallel lines because of the alternate interior angles, we say yes, and that's the definition of a parallelogram. Now the next one, we have a lot of options here. Okay, we can say definition of a parallelogram because the alternate interior angles are congruent. We can also say this is 80, this is 80, this is 100, so therefore this has to be 100. We could say consecutive angles are supplementary, or we can say what I'm going to go with, opposite angles are congruent. You do have three options there that you can use. Definition of a parallelogram, consecutive angles are supplementary, or opposite angles are congruent. Next one is pretty straightforward. It's yes, a parallelogram because the diagonals bisect. Next one, our vertical angles are equal and our linear pairs add up to 180, but that has nothing to do with proving you have a parallelogram. So this one is a no. The next one is also a no because literally we have a pair of alternate interior angles that are not congruent. Therefore, one pair of the sides are not parallel. Only these two sides are parallel, which makes a trapezoid, not a parallelogram. So these two are no. Down here, when you have congruent triangles, okay, and AED is congruent. I know that's not that neat, but I want you to be able to see it, is equal to CEB. We have a few options here. Since the triangles are congruent, the alternate interior angles have to be congruent because corresponding angles of congruent triangles have to be congruent. So we could say, yes, definition of a parallelogram. We could also say, because these angles right here are congruent, we have a parallel line, and since the triangles are congruent, we have the same parallel lines also congruent. So that's the reason I'm going to give. I'm going to say yes, is one pair of sides are parallel and congruent. And finally, right here, ABC, we're going to go with this right here, ABC. So ABC is this triangle right here, and CDA, which is this triangle right here, okay, both these triangles are congruent. That's congruent to that then, corresponding sides. These two sides corresponding or congruent to these two sides. So both pairs of opposite sides are congruent. That's the reason I'm going to use. Now, I could use other reasons as well. I think this one is by far the easiest. Opposite sides are congruent. Now, in this picture, we have a rectangle. Okay, and I'm going to allow you to assume this is a rectangle. I probably should have wrote it here, but I will say it's a rectangle. So right away, I think most of you probably know that opposite sides have to be congruent in a rectangle. You probably knew that even before you walked into the class. So this ends up being x equals 3. And when I plug that in, 5 times 3 is 15 plus 1, I get 16 for my length here. And 8 times 3 minus 8 is going to give me a length of 16 here. My y's also have to be congruent. So 9y minus 6, my y's don't have to be congruent. Sides represented by an expression with y obviously have to be congruent. 5y plus 2. So when I do that, I get 4y equals 8, and my y equals 2. Basic enough. So 9 times 2 is 18, minus 6 is 12. And 5 times 2 is 10, plus 2 is also 12. Now, to get my w, it's a rectangle. So these two angles that are represented by 6w minus 1 and 10w minus 5 have to add up to 90. So I get 16w minus 6 equals 90. Oops. 16w minus 6 equals 90. 16w equals 96, and my w equals 6. When you plug w in for 6, 6 times 6 is 36, minus 1, we get 35 for this angle. And 10 times 6 is 60, minus 5, we get 55 for this angle. Now, I also want you to find all the missing angles and sides. Well, in terms of the sides, 12 squared plus 16 squared equals 20 squared. Each diagonal has got to be 20 through the Pythagorean theorem, which means each diagonal bisected has got to be 10. This is 10. This length is 10. This length is 10. And this length is 10. Okay, oops. There we go. It's 10 here, 10 here, 10 here, 10 here, which means I have 4 isosceles triangles, which means base angles have to be equal. If this is 35, this is 35. And at the right angle, this has to be 55. It's an isosceles triangle, so this has to be 55. Therefore, this is 35. This is 35 over here. This is 55. In the middle angles, well, triangles add up to 180. 55 and 55 is 110. This is 70. So therefore, this is 110 as a linear pair. Vertical angle is 70. Vertical angle is 110. And those are all the angles and sides of my rectangle. For my rhombus, and on the test you'll be told rhombus, I probably should have put there as well. Right away, all 4 angles in the middle have to be 90. So I'm going to write that down right away, and then I'm going to get my y. This is 90. This is 90. Oops. And this is 90. Okay. And now to get my y, it's simply 6y minus 30 equals 90. 6y equals 120, and y equals 20. Angles in a rhombus, okay, where you have diagonals, well, the diagonals bisect the opposite angles. So since it bisects, these two angles have to be equal. So that means 11x minus 25 equals 8x minus 10. So we end up with 3x equals 15 and x equals 5. 8 times 5 is 40 minus 10 is 30. So this is 30, and therefore this is 30. And it's still a parallelogram. So the alternate interior angles have to be equal. 30 and 30. Okay. And then 36, 90, what adds up to 180? 60. 30, 90, 60. And then my alternate interior angles, 60 and 60. Diagonals bisect. So this is 3, this is 3. This is 4, this is 4. These are the diagonals bisect. And now at the right triangle, I'm going to use Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. So my W has to be 5. Since it's a rhombus, literally every side on the outside has to be 5. Because all 4 sides on the outside are literally hypotenuse to the triangles in the middle. For a trapezoid, oops, that's not isosceles, okay? We have a mid-segment, and then we're trying to find angles, right? The trapezoid with its mid-segment, the mid-segment has to be parallel to the 2 parallel sides of the trapezoid. And that parallel mid-segment is literally going to create 2 more trapezoids. So the bigger trapezoid right here, we have same side interior angles. These angles have to add up to 180. So now we have 14x plus 40 equals 180. 14x equals 140. And x equals 10. And I'm always a big fan of plugging the numbers in. We get 55. 90 and 135 is 125. And what you'll notice is corresponding angles also have to be congruent. This is 125, and this is 55. Okay. Now over here. Okay, now solving for y, we're going to do the same thing because those are supplementary angles. They are same side interior angles. So I'm going to add them up and set them equal to 180. All right, we're going to get our 6y plus 60 equals 180. Our 6y equals 120. Oops. And y equals 20. And when I plug that in, I'm going to get 54. 2 times 20 is 40 plus 14. And 4 times 20 is 80 plus 46. So I'm going to get 126. Okay. Corresponding angle is 126. Corresponding angle is 54. And I know it doesn't look right. It doesn't matter. And that's actually done intentionally. Okay. Same thing over here. I know they don't look right, but you have to go with the angle that you get from the given math. Okay. And if you notice, as you add these angles up, you will get 360. It's a four-sided figure. Now for the z, we need to remember the mid-segment is an average of the two bases. So how do I write that out? Well, we get 3z plus 2 plus 6z minus 7. And I'm going to take the average of that. That means we're dividing it by 2. And when I divide that by 2, I should get my mid-segment, which is 4z plus 1. Now I'm doing basic algebra. I'm going to multiply both sides by 2. The 2 cancels on the left side, so I'm left with 3z plus 2, 6z minus 7, and I multiply by 2 on the right side, and I get 8z plus 2. And now it's basic algebra 1. 9z minus 5 equals 8z, 8z plus 2, and we end up with z equals 7. When I plug those numbers in, we get 23, we get 29, and we get 35. And you'll notice 23 and 35, the average of them is 49, which is the midsegment. When you have an isosceles trapezoid, essentially you just need to know that diagonals are congruent. I know there's no diagonals in here, but we know that diagonals are congruent in an isosceles trapezoid and that the base angles are equal. So literally 11z plus 7 has to equal 62. So 11z equals 55 and z equals 5. Therefore, this angle right here is going to be 62. It also means, oops, I put down 63. Let's put the correct number down, 62. Okay, it also means, since they have to be supplementary, this is 118, and this angle has to be 118. So if I want to get my y, 9y plus 10 equals 118, 9y equals 108, and y equals 12. Here, 3x minus 2 equals 118, and 3x equals 120. My x equals 40. So that's how I get the x, y, and z for the that are in this trapezoid.